Hey everyone, welcome to today's Explainer. I am super excited to dive into this with you all because today we're tackling something absolutely fascinating, the foundations of supervised learning. We're going to look at how computers actually learn from data. Instead of just sitting there following rigid, pre-programmed instructions, it's basically the hidden magic running our modern world.
But before we get into the machines, let's ask a really basic question. How do humans learn new things? Think back for a second. Think about when you were a little kid, learning to spot different kinds of fruit, or when you first tackled algebra. You didn't just magically know the answers, right? A teacher showed you examples and, crucially, gave you an answer key. They pointed to a red sphere and said, hey, that's an apple. You practiced, you messed up, you got feedback, and eventually, you learned the pattern.
And honestly, that brings us right to the core of what we're talking about today, supervised learning. This is a type of machine learning where AI systems learn from labeled data to make predictions or decisions accurately. It turns out, AI learns exactly like a student in a classroom. So the crucial point here is that supervised learning fundamentally requires a teacher. The AI needs someone or something to provide all the correct answers right up front so it can start making those intelligent connections. Now, you might be wondering, what exactly do those correct answers look like for a computer? Well, that's what we call labeled data, which is just information that includes correct answers or categories. Think of it like flashcards. If you want to teach an AI what a cat looks like, you don't just dump a massive random folder of photos on its virtual desk. No way. You hand it thousands of images that explicitly have a checkmark for cat, and thousands of others clearly marked with an X for not cat. Those explicit labels, they're the literal flashcards the AI uses to study. So, how do we take those flashcards and build a complete learning process? Well, there is a 4-step playbook to get a supervised learning system up and running. Step 1, collect the data. Images, text, audio, whatever we're working with. Step 2, label the data. This is us humans writing the answers on the back of those flashcards. Step 3, train the AI. This is where the machine furiously studies the patterns connecting the inputs to the correct outputs. And finally, step 4, test the AI. We throw brand new, unseen data at it to see if it can predict the correct answer completely on its own. It is exactly like studying for weeks with an answer key and then sitting down to take the final exam. And this brilliantly illustrates how the process works in a scenario you've probably already dealt with today, your email inbox. I mean, how does your email know what's junk and what's actually from your friend? Well, during its training phase, the AI studied mountains of labeled emails. It looked at thousands labeled spam and learned the red flags, suspicious links, weird repeated ads, or that prince offering you $1 million. Then, it looked at emails labeled safe, containing just normal text. By studying those contrasting patterns, it learned to automatically filter our inboxes so we only see what matters. It's essentially taking its final exam every single time a new email pings your phone. Moving on to Section 1, AI in the real world. We've got the mechanics down, but let's see how this actually shows up in our everyday lives, outside the inbox. Because it is literally everywhere. In healthcare, supervised learning helps doctors with disease detection by learning from thousands of labeled historical records and x-rays. That smartphone face recognition you use to unlock your screen 50 times a day, yep, it studied countless labeled face images during training. We've got online shopping recommendations driven by oceans of past customer data, weather forecasting, and even educational learning apps. By constantly studying all this historical data, the AI makes real-time predictions that just make our lives easier and a whole lot more personalized. Now for Section 2, the good and the bad. Because as amazing as all this sounds, every technology has its trade-offs, and supervised learning is absolutely no exception. Okay, let's dive into this reality check. On the advantages side, we get incredibly high accuracy and blazing fast decision-making. Plus, as the system ingests more data over time, we see continuous improvement. But flip over to the limitations. Getting that high accuracy needs a massively large amount of labeled data. And remember, humans usually have to manually label that stuff. That is super time-consuming and expensive. Also, if those humans make mistakes, we run right into serious data quality risks. If the AI trains on biased or incomplete examples, it's going to fail hard when it sees something totally new. Which leads us perfectly into this absolute gem of a quote. AI systems do not truly understand information. They learn patterns, predict answers, and follow mathematical relationships. I really want you to let that sink in. The AI isn't actually thinking like us. It doesn't know what a cat is or why getting a spam email is annoying. It's simply matching mathematical patterns it memorized during training. And honestly, that is exactly why human monitoring and high-quality data are absolutely crucial. We can't just blindly trust the machine.
So as we pull these core concepts together, here's your major takeaway for the explainer. Supervised learning depends heavily on human guidance, quality data, and responsible system design. And AI is literally only ever as good as its human teacher and the data it's fed. It's a wildly powerful tool for sure, but it requires our constant responsibility, careful planning, and human oversight.
And that brings us directly to your mission. For your homework, I'm challenging you to design your very own supervised learning system. What real-world problem would your AI solve? Maybe it's detecting fake news online or spotting healthy versus diseased plants in a garden. I want you to describe the task, the exact data the AI would need, the labels you'd use, and crucially, the limitations of your system. Remember, the machines are doing the learning, but we're the ones teaching them. So the ultimate question is, what are you going to teach them? Thanks for hanging out with me on this explainer. Keep asking those great questions, and I'll catch you next time.